Hey guys, so we've looked at writing expressions for both basic math phrases and also from real life scenarios using those keyword chart. So we've also looked at evaluating this year. So today we're going to put both skills together. So just as a quick review, you see here in the middle of my screen is a little review about evaluating. So to evaluate an algebraic expression, we would be replacing the variable or letter with known values. So we take out the letter and we put in an actual number. Then we use the order of operations to solve. So let's take a look at two quick examples just to kind of refresh how we evaluate. So this first one says evaluate each expression below if x equals 5 and y equals 6. So let's look at this first expression. We have x plus y minus 9. So again, if I'm going to evaluate it, I'm going to replace my variable with the actual number. So I have an x here, and we know x is 5. And we're going to keep all the other operations and all the relationship in the expression the same. So we're going to have a plus sign. And then instead of writing y, we know y is 6, right? We've got a y here. And we're going to take out just that y and we're going to put in our 6. And then we have a minus 9. And that's just part of my expression that I'm going to continue. Then from here, using the order of operations, we solve left to right. So 5 plus 6 is 11. 11 minus 9. And then 11 minus 5 simplifies down into one answer of 2. And again, you can use a calculator for the computations, guys. Just make sure that you're entering in things correctly and looking logically at your answer. All right, second expression, we have 3x plus 2y. So again, you should notice that we have an x here. And according to our problem, we know x is 5. And then we also have y is 6. And according to our problem, y is 6. So we're going to take those out and replace them. Now, be careful when you see a number buddied up directly with a variable. It's tempting just to say 3, okay, I'm going to take out the x and I'm going to put in a 5, and then all of a sudden it looks like 35, right? But if I look at my original operation and my relationship between those, it's 3 times x. So you have to make sure that when you are evaluating that you don't lose the relationship there. So it's 3 times 5. Actually, I'm going to go ahead and erase and space it out there a little bit because it's hard to see. But we'd have 3. Here's my multiplication. And again, I'm just using that color scheme so you can help see that I'm just replacing just the x with that value of 5. And then plus 2. I'm carrying on here. And then again, same thing with the y. It's 2 times y. So 2 times 6. Then solving left to right. Multiplication comes before addition, or again, you can grab a calculator and put in your computations, but 3 and 5 make 15, plus 2 times 6, which is 12. So you have an overall single term answer of 27. All right, so we're going to be looking at how we use that for evaluating those basic math phrases. So remember, we've been looking at writing expressions, given phrases, given real world scenarios. So we're just going to, again, kind of put it all together. So we're going to have a math phrase. We're going to turn it into an algebraic expression. Then we're going to add on that idea of evaluating it for a certain number and then finding your single term answer. We talked about variables are used to represent an unknown number. And often in phrasing, it's said as a number. So although I mentioned you can use any letter to stand in for a number, we're going to use X for all these examples just to be consistent. All right, so if I take a look at the first one, and again, that keyword chart that you've been looking at could still really be helpful if you're not as familiar with some of your words. So the first one here says a number added to 4. So as you can see, added to is pretty straightforward. It's a general term for addition. So we have a number added to 4. Again, we're going to use X for number. Added means to add, and we're adding it with 4. Then we're going to evaluate it. What if X was 2? So again, for all of these problems, you're going to be taking out the variable and putting in a number. So I'm going to say 2 plus 4, because again, I took out my X and I plugged in a 2, because that's what it told me. What if X was 2? Then you're going to go ahead and solve to say 2 plus 4 is 6. All right, let's take a look at number 2, 12 divided by a number. So again, divided by is pretty straightforward, general operational word for division. And if I move left to right, we have 12 divided by a number. And again, when I don't know what it is, we're going to use x. Then we're going to move on over and evaluate it. What if my x is -3? So we're going to take out, and I'm going to say, okay, here's my x, and I'm going to plug in a -3 where I see that, and I'm just going to show my work. 12 divided by -3. Remember that fraction bar is the same thing as your division sign. Either one would be okay, although I find on a computer that slash bar is a little bit easier to find as far as operations. So 12 divided by -3 is -4. Look at the next one, a number -10. Again, minus is another one of those basic words that means subtraction. So we have a number -10, and we're going to evaluate it for 27. So we're going to take out our x and put in a 27. So we're going to say 27 minus 10. Now notice everything else is staying the same. I had a -10 over here, so we're going to have a -10 over here. The only thing I'm replacing is that variable, that x. So completing my problem there, 27 minus 10, bringing it down to a one-term answer, I get 17. All right, now the last three on here have to deal with those those yellow, green, and blue phrasing. So if you remember, quick review of our chart here. See if I can make this come on top. Okay, it's not going to go on top of my words. But anyways, I'll move it down here. So you remember, green implies operation in numbers. If you see words like double, triple, twice, or half, it tells you the operation and it tells you by what number. Yellow, if you remember, switches the order, meaning that you have to flip what number you write down first and what number comes second. And then last, we looked at blue wording there, sum, total, difference, product, and quotient. Those are the words that we need to make sure when we're writing the expression go in parentheses. So be careful of those. So if I take a look at this next one here, twice a number. Now, if you notice it's italicized, I did that for a reason, to draw your eyes to it. Hopefully you realize twice means multiply by 2. So it is a green word. So I'm just going to go ahead and highlight a green just so it sticks out in your memory. It's a green word. Twice a number means I'm going to take a number and multiply it by 2. Oh, looks a little wild. Let me get my pen. 2x. Then again, evaluating it. 2x is 2 times x, 2 times 5. Now again, you can use parentheses to show it. You could also show it with a dot. Just try to stay away from that x when you're showing multiplication. Following through with the multiplying, 2 times 5 is 10. Okay, the next one, 3 less than a number. So again, according to our chart, any words that had had than or from, we talked about were really important because we have to switch the order of construction. So 3 less than a number would mean I have to construct it like this. Less than means to subtract, and I'm switching the order of my terms. Plugging it in for evaluation, we're taking out our x and putting in a 14 because that's what it tells us in this problem. So 14 minus 3 gives us an answer of 11. Okay, last one for review for today. The difference between 12 and a number times 2. Now, hopefully you're able to see there, and if not, you can take a look at your keyword chart, but we have the difference in here. The difference between 12 and a number. And if you notice, it's italicized. I tried to italicize or make your letters slant so that you realize you should maybe look at your keyword chart or look. And my apologies, I can't seem to get it in front of my wording here. Here's the word difference, and it is a blue term, meaning that it implies the operation, and it tells you to use parentheses around that section. So if I have the difference between 12 and a number, I would have to put subtraction of 12 and a number, and then put it in parentheses. And then follow the rest of it. It says then times 2. So 12 minus x times 2. So going to evaluate it, I have 12 minus 7, and then we're multiplying by 2. Order of operations would do the parentheses first, and then you multiply by 2. So 12 minus 7 is 5 times 2, and you get the answer of 10. All right, so that's what you're looking at doing today. You are looking to write the algebraic expression from your math phrase, then take out that variable and plug in the answer or the number it tells you it stands for, and it will be set up just like this. Then following your order of operations using a calculator, whatever method you prefer, you will then tell me your answer. So good luck, reach out if you need help. Again, I have work sessions available each week, and if you participate and meet up with me, you'll get participation points that can help bring up your grade. So good luck, and again, reach out if you need it.